Storing all of your data in a single database table may seem like a good idea, but it isn't. And in this video, I'll share 5 reasons why it's not a good idea and what to do instead. Let's start with an example. We've got some information about some customers here. We have a name, email address, the company they work for, and their account status. Let's say we want to put this data into our SQL database because we're building a simple application to view customer data for our business. And to make things easier for ourselves, we'll just store it in a single table. Here is what it could look like. We have a single customer table with an ID column that we have added, and then all of the data we just saw. Let's create this on our database. I'm using MySQL here, but this works for any SQL database. I'll create the table that we just saw. Next, we'll insert this data. The data is now in the table. Let's select from this table. We can see our customer records here all in a single table. However, there are several issues with this. The first issue can be demonstrated by adding some new data. We can see in our existing results that there's a column called Account Status. This indicates the status of the customer's account, and it has values such as active, cancelled, or pending. I'll insert a new record for a new customer. I'll add the name and other details. When I get to the account status, I'll add in a value of active. But let's say that I type the value like this, which is slightly different to the existing active value. We can run this statement and it is successful. There are no errors or problems with running this because the database can see it's a string inside a text value. It doesn't know that the value is misspelled. Now, when we look for a list of active customers, this new record won't show up. We would have a query like this, where we query the table and filter on records where the status equals active. We can run this and we see the active records, but we don't see our new record. This is because the new record has a status value that does not exactly match this value in the where clause. So we don't have a complete list of active accounts. In this example, we could correct the data if we know it's incorrect to fix the spelling. However, what if we inserted a record with a value of open instead of active? We can run this and it is inserted. But what does open mean? Is it a new value that we need to capture and it's different to active accounts? Or does it mean the same as active, and if so, should we rename all the active values to open, or something else? Having this column as a free text entry like this can cause these kinds of issues. The second issue happens when we update the data. Let's say we change this customer's account status from cancelled to inactive. We can do this using an update statement just for this record. We can run this and see that it is successful. Let's see the results of the table. We can see this row has been updated from cancelled to inactive. But what does this mean and why did we do this? Has something happened to this specific customer that means it needed to be something different to cancelled, so we have a new status of inactive? Or is the cancelled value better reflected by the value of inactive, and we should use inactive instead? Said another way, has the value of cancelled changed, or is this a new status? If the value has changed, then we need to ensure that all of the other cancelled records are updated to inactive. If we do this, there's a risk that we miss some values with our SQL statement. This is called an update anomaly in SQL and database terminology, and it's something we want to avoid. It's where we update some data, but we don't completely update all of the data we need to. The third issue is called a delete anomaly. I'll show you what this means with an example. Here is our data. Let's say we want to remove this customer from our system. Perhaps they are a duplicate or no longer needed, or for some other reason. Notice that they just happen to be the only customer with a status of pending. So we write a delete statement to remove them. We run this and it is successful. Let's check the customer table again. We can see that our deleted record is not shown. However, as part of this operation, we've also removed the last record that has a status of pending. We now have no knowledge of the status of pending. It does not exist. This happens if we remove the last record that has a particular value, and we lose all information about that value. Reason number 4 why this is not a good idea is that we're storing duplicate data within our table. We've got multiple records that have this value of active. You're probably thinking this is good, And you're right, we should have multiple active customers. If we had one, then it would be hard to have a business. But we have this value or label of active stored in many places. If we need to rename it, it's in many rows. So we have this stored in many places, meaning we have duplicated the data. It's better to store it in one place and refer to it from many places. Before I explain what that means and how to do it, let's look at reason number 5. Reason number 5 is that you can't add any additional context to this value. Let's say you wanted to add a bit of a description to each of the status values so you could show more information on a web page or you knew what it was for. To do this with this design, you would have to add another column to this customer table and add the same description to each row. This will mean we have the same issues with this column too. Having the data in the same table means we can't add any extra context to our records. So what's the solution to this? How do we solve these problems? The answer is to create a separate table that has a list of possible values. This is often called a lookup table, and it's a common way to handle this issue. We can then refer to the appropriate record from the main customer table. Here is what the design would look like. I'll show you what the data looks like in a moment, but first I wanted to explain what this line here means. The customer table has this status ID column. This FK means it's a foreign key, which means it represents a primary key in another table. In this example, the line points to the status table here. So the column here relates to the primary key in the status table. Each row in the customer table will have an ID number which relates to the relevant record in the status table. Here is what the data in the lookup table would look like. Each row has a unique ID value. Then there is a column that has each of the status values. Each value is only defined once. Let's write the SQL to see what it would look like in a real database. First, we have the create table statement. This is how we create the new lookup table. We have our 2 columns here and one of them is a primary key. We run this and the table is created. Next, we can insert some data. We'll write an insert statement to insert all of the records at once. We specify the IDs and the status values that we want in the table. We can run this statement and the record is inserted. Let's see what's in the table. We can write a simple select statement to get the data from this table. We'll select both the ID and the value columns. We can run this and see our records here. What about the customer table? In our diagram, this had a column for the status ID, but in the customer table now, it just has the status value. First, we'll add the status ID column to the customer table. We can do this with an alter table statement. We write this statement specifying the name and data type of the new column. We run it and the column is added. Now, before we add data to it, we should add a foreign key constraint. This will ensure that we can only add values to this new column that exist in our status lookup table. To do this, we write another alter table statement and add the foreign key constraint. This relates to the lookup table we just created. We can run this and the constraint is added. Let's add some data to this table. How do we know what values to add? We have the lookup table here which shows the ID values and the status values. So in the customer table, we will set the status ID value to 1 where the status is active. And then we'll have similar statements for the rest of the values. Let's see the customer table. This is what the data looks like. We want to write some update statements to update this status ID column. Here's what the first one would look like. We update the customer records that have a status of active. We can run this and the data is updated. Then we repeat this for the other status values. We can run these statements and the data is updated. Let's see what the table looks like now. We can see the status ID values are populated for all of our records. Now that we have done that, we don't need the status value here because the status ID is the column that stores the status. So let's remove this column. We can do this with an alter table statement to drop the status value column from the customer table. We run this and it is successful. Let's see the customer table. We can see our records here and no longer see that status value. You're probably wondering, now that we have the data split across 2 tables, how can we select the data in one query? It seems like we've gone backwards, but I assure you we haven't. You'll want to watch this video next to learn exactly how to select data from two tables in a single query, which is something you'll do a lot in SQL.